On this presentation, we will look into the proposed control relay circuit of proposed dynamic load balancer on medium voltage distribution line. As introduction, we need to analyze what is the problem. Global warming is the main reason why the unbalanced network is imminent, as more and more single-phase loads will soon be added to the network. The electrification of transport means the charging facility will add burden to the grid, and this will have unpredictable load demand. The air source heat pump, which is now subsidized by the government. It is gaining popularity as £7,500 grant is available until 2028. This is another single-phase load with unpredictable demand. The net zero target of the government will sure put pressure on distribution system. On present-day distribution line, a single line diagram is shown. Under the displayed feeder there are 45 single-phase transformers and just 7 three-phase transformers. The feeder will soon be unbalanced due to increased unpredictable single-phase loads, and this is due to the net zero program of the government. The single-phase transformers are permanently connected to one of the three phases. Balancing the system dynamically is not possible currently due to this limitation. The transformer connection as shown in the image is permanently connected to phase conductor. If the distribution operator wishes to transfer the connection to other phase, the primary leads could be too short or too long. The transferring of primary lead connection is time-consuming, and on most cases, it's need power interruption to facilitate the transfer of transformer connection to preferred phase. The difficulty of transferring the primary leads connections can be lessened if hotline clamp is used as shown and the leads are with the correct length. This can be loosened and retightened using grip. All tools and highly skilled line personnel are needed to facilitate the transfer of phase connection. On the transformer primary connection shown, the primary leads are connected using permanent line connectors. The transferring of phase connections on this case needs power interruption. Therefore, it is costly and not convenient for the service users. The type of connectors shown are the ones that are difficult to remove without interrupting or de-energizing the grid. The amount of time needed vary depending on the status of connections. The proposed new hardware will facilitate the transfer of phase connection without undoing any primary line connectors. The hardware will have 5 high voltage bushings. The 3 terminals for the phase conductor supply and the remaining 2 for the single-phase transformer concerned. The idea is to transfer the phase connection by selecting the desired phase either by remote switching or via local manipulation. The hardware will be installed before the primary bushing of the transformer, and the control circuit can be installed on the height that only trained personnel have the access. This idea can be expanded to fully automated operation using the artificial intelligence by predicting the behavior of the system and reacting dynamically. The current study is focused currently on the control circuit. The design of control circuit is shown on the diagram. The interlocking circuit will play an important role to avoid the energization of unwanted phase. To demonstrate the switching action of the design circuit is to analyze the circuit one phase at a time. For phase AB, by pressing the spring return momentary contact push button will energize the coil A and B. The corresponding normally open contact will hold the supply for the coil. The normally closed contact of R1 and R2 will remain closed until the selection is changed. The R3 interlocking coil will be energized using normally open contact of A and B coil. Since R3 is energized, the phase CA and BC will never be energized because of the R3 interlocking. This is because of normally closed contact of R3 will prevent the flow of current to the coil. This is the prototype of the design circuit. The 3 main coil represents the contact for the medium voltage phase with several auxiliary contacts. The relays are for the interlocking to facilitate the energization and screening of the phase concerned. The terminal blocks used and push button are only accessories that industry-graded equivalent should be used. This analog version will be compared on the next phase of research using the microcontroller to control the circuit. The potential of this concept is promising as this is scalable from medium voltage distribution to residential load balancing. The advancement of AI, artificial intelligence, needs the infrastructure to be adaptable to the changes. The collaboration of different fields of specialty like electromechanical specialist, embedded system programmer, high-voltage electrical engineers, and industry manufacturers are essential for the success of this new hardware. The integration of TE's hardware to SCADA, supervisory control and data acquisition, is the next step of this study.